Hey guys, thank you for joining us and coming back from the coffee. I wasn't too eager, but yeah. We're gonna talk a little bit about our experience with going 100% Kubernetes in a production component. A little bit of background: we come from Blip. It's located in Porto. It's part of a larger organization, Paddy Power Betfair. It's on online betting. And internally, we have an on-prem cloud deployed with OpenStack and a bunch of other components you're going to see later. And we've decided that the future is or is not cloud. So it's both true and false at the same time. So we needed to make sure. And we started 3 simultaneous proof of concepts for 3 different archetypes of applications we have. So we had one with Windows applications on Azure. We had one for Linux VMs on AWS. And we had one for containers in GCP, GKE. And this is the one we're going to talk a little bit about. So I'm going to hand over to João.
Yeah, so I'm not an Apple engineer. I'm an automation engineer. What our team does, we work on the platform that we provide to developers, kind of like a platform as a service. Mm-hmm. So we're not giving them just straight up VMs. We give them something they can work with, don't need to mess around with more low-level stuff. So the goal for this POC was to have a complex application running in production on Kubernetes and with proper security, logging, monitoring, etc. Basically, we didn't want to go with the easy approach, basically getting some front-end Angular application and Angular, Node.js, whatever, running in Kubernetes. It's pretty much built for stateless stuff. No, we needed like a proper component and all the logging, monitoring that you need to properly operate something, not just, yeah, we have it running, so it's fine. And this was supposed to be something kind of like a drop-in replacement. So the devs wouldn't need to go and check their metrics on some different dashboard, logging on some different application. No, all the metrics will go to our Grafana and OpenTSDB. All the logs will be going to our Splunk instance, and so on and so forth. So we had a bit of a tight timeline. It was 8 weeks. So we had some assistance from Google and from a consultant company. And one of the end goals was to actually serve external traffic. This is an application that receives traffic both internally and externally. The application should be platform agnostic, meaning same code base, developers, and the application itself doesn't need to know if it's running here or there. Also, the rollout itself, if it's running on GCP, AWS, some basement somewhere, it's completely irrelevant for the traffic, for the incoming traffic, be it outside infrastructure or inside. So a couple of caveats once in a while. Before you start, if you do something like this, you need some stuff that sometimes takes way longer than it should, like ensuring that everyone has access to the platform, in our case through our SSO platform. Also network connectivity, because it's not a standalone component, so it needs to interact with our data centers. So ideally it should be some kind of direct connect, but in this case, to save time, we ended up using a VPN, which ended up working surprisingly well. And also billing, because someone has to pay the bill at the end. So our current infrastructure, it's on-prem, and it's quite a big thing we're talking about. We have 2 active data centers. Traffic comes in through UltraDNS that balances through those data centers. Then it hits NetScalers that bounce the traffic inside. Then Nuage for software-defined networking. And then below all that, OpenStack. Our philosophy with this infrastructure was to try and go for immutable deployments. Basically, that whole cattle versus pets debate. We ended up going with cattle. And we use Chef or Ansible for config management. And right now, this is the new infrastructure we built a couple of years ago. Before that, we had like Zen hypervisors and more low-level stuff. Right now, we have about 600 different applications, because who would guess that betting websites would be complicated, and about 12,000 virtual machines across both data centers. So we're talking about a bit of scale here, not like Amazon scale or whatever, but it's an interesting challenge. So the application itself, it's a Java microservice. I'm talking microservice because it does one very specific thing. Problem is, it's a behemoth. It eats through 48 gigabytes of RAM, one instance. And we have 12 production instances across both data centers. On a busy day, which is usually Saturday afternoon, each node will be doing about 7,000 requests per second. And it's built like mostly Java applications are built. It's a Maven that builds an RPM, it's installed on a VM, then configuration management kicks in and configures the remaining bits. Right now it's maintained by one team that has 6 active developers. And during this POC, we wanted to minimize this impact on them. So it's the same code base. There's no extra branches and forks and building an RPM in a different Jenkins job. It's the same CDCI tooling. We use ThoughtWorks Go to automate the process. It's the same thing. You don't need to go to Spinnaker or here or there. It's all the same. And it's also the same bundling process. One of the trickiest parts was actual config management, because if you're thinking about running Chef or Ansible or whatever in containers, just don't. It's just wrong. So what we ended up doing was having a way to convert the Chef cookbooks into config maps, so we could configure the containers and not having to do some weird voodoo stuff. So right in the beginning, we hit a few questions, like, what's the right size for a cluster? How to distribute the applications across the multiple clusters? How to implement inter-cluster communication? How should we minimize it? And well, it's one of those questions that even we were a bit at odds with this. The consultant company was a bit at odds with this. And final answer was, guess what? It depends. So our initial design, we ended up being with something that probably was a bit more complex than needed, because we wanted to make something that was not just a throwaway POC. It was meant to be thrown away, but we wanted something that would give like a structure that we could build for the futures. So we have the main organization in GCP. We separated folders for each brand, then a subfolder for each business unit, which kind of mirrors what we already have in our current OpenStack infrastructure. We have different tenants for that. And then we'll have separate clusters for dev and for prod, because it's always good to separate these things. Yeah, but folders were very, very nifty in order to give some logic structure, otherwise it would become a mess really, really quickly. And regarding the VPC structure, we ended up using each project will have its own VPC for isolation. And then all of those will be channeled through a shared VPC that will end up flowing all the traffic through the VPN into our premise network. So how did we start with this? We used GKE, but the node tenants and all of that base infrastructure uses normal VM, so we had to interact also with the greater GCP ecosystem. So we started with Terraform. In our framework, we use mostly Ansible, but at the time, I'm not sure if it evolved in the meantime, at the time the Ansible support was very, very shady. No pun intended with the shady library. And it's also provided by and maintained by the Google engineers, so it should work fine. And also the beta features were clearly separated, so we didn't have that problem with unknowingly using stuff that might end up breaking in the future. And also one of the issues some people have with Terraform is saving the TF state. In this case, we can just use storage buckets and all's good. There was a Kubernetes provider, but at the time it would be very interesting, but it didn't quite do what we wanted, so we ended up just skipping it. So, on to the rest of the juicy stuff.
So João talked about the process of setting up the clusters and setting up the GCP and JK bits. I'll talk a little bit about using the infrastructure we just set up. So one of the key components in the beginning was we will try to disrupt the minimum possible of the development team. So they're currently developing features. They were almost not aware of this whole thing happening. So we were doing this based on their application. It was a good sample application, heavy enough, a good representative application of most we have internally. So they were still developing features. They had their own Scrum cycle going on. And we just got to them on occasion, hey, I have a question about your application. Can I do this or that? And one of the major things we tried to do was not change the code, not change config management, don't have them writing config maps and chef cookbooks at the same time. And since we have no precise scope of when we were going to go live, we couldn't say on 3 days from now, we will port all the configs from Chef Cookbook, dump them in config maps, and that's it. No one touches it ever again. They were continually deploying. If they did a breaking change in their on-prem deployment, it would be reflected on Kubernetes cluster without them knowing and without us having to worry about it. So what we actually did was we tried to put a big Java application that was being deployed with Chef Cookbooks on VMs, and we tried to somehow get it into container. The first solution was to actually run Chef Cookbooks inside the container, and we're sorry for it. The end image was like 1 gig to 100. It was ridiculous. It was working, but very poorly, and we immediately dumped it. This was a tight schedule. We tried not to reinvent things, and we stumbled upon the Jib plugin. It was made by Google to actually port Maven Java applications into containers. So you can actually go to your POM file and say, I want to create a Java application based on the source code I have. And when you run Maven build, it will actually build an RPM and a Docker image based on it. The downside is it only has the application code. It doesn't have config management. And config management was a big part. If you have the RPM alone, it does nothing almost. So our approach was to actually get a VM, sample VM with Test Kitchen or whatever, a Vagrant box, run Chef Cookbook on it with all the environments, then diff all the file system, get all the differences, and cherry pick those into properties files for config maps, for Kubernetes config maps. And that actually worked quite well. Every time the developers changed the application, Jib would pick up the RPM and a Docker image. And every time they changed Chef Cookbooks, we would run our custom Python script. It would instantiate all the environments they have, QA and next integration and pre-prod and prod. It would cherry pick the differences and dump them into a YAML config map Kubernetes file. And this was all done very live and lightweight. It was a really good experience. So we got config maps handled. We got the base Docker image handled. And now we need to create the Kubernetes deployment. This usually is given to the developers to do. Ideally, flat infrastructure, no handoffs, no silos. The devs own their own deployment files, Kubernetes deployment files. But we didn't want to get the devs so involved in this, so we had to do this for them. And we had to expose the minimum thing they would have to write. And the minimum thing was basically nothing. So eventually they ended up writing this file on the right. And that's the only thing they see as far as I'm in Kubernetes. That's the only file they know. They have their own, the name of the TLA, it's a service name, what image they're based on, what project they belong to in GCP, and that's it. And secrets if they want to inject them, their clear text, because why wouldn't they? And on the left is the deployment file, the actual deployment file that we, the infrastructure team, owned. And initially, we were about to use Helm for this, and Helm was a big behemoth. It was a big application, does lots of things. It does deployments by itself. You can just say deploy this thing. It does config, almost dependency management, and we didn't want any of it. So we actually created a little thing called Rudder, which is basically a small Helm. We created a little tool called Rudder. It does Jinja templating. It's a Python library. And it does basically what we want. And this was a hard trade-off to do. We're trying to go with industry standard tooling. We were trying to not reinvent the wheel, but this time it was worth it to do a small thing. Took an afternoon, and we were able to pick the file on the right, smash it into the file on the left that we owned, and ta-da. And this is a valid Kubernetes deployment file. So in the end, the developers owned two things. The Docker image that was based on their source code. They owned the config maps, which were based on the config maps, the chef cookbooks, and we owned the Rudder templates. And from each of those, this is basically a deployment pipeline. Any of those change, we do a Jenkins build, we do asserts, validations, schema checks, whatever. We create a little manifest, deployment manifest file it's something we internally in Paddy Power at Ferreira we use. It's a snapshot in time that snapshots the infrastructure, the config map, the configurations, the application, whatever. You can redeploy these from 1 year ago or 2 weeks ago, and they should deploy just fine. And we use GoCD to deploy this using our internal Rudder template, the whole thing, push it to Kubernetes cluster, and then do a round of validations with Jenkins tests. And these were the actual same tests they used in our on-prem. They just didn't know. We just exposed a new endpoint, run these tests against a new endpoint besides our two internal DCs, and everything was working fine. So after we went live, or going live, this is what we saw. The latency times through the VPN were lower than expected, to be honest. Comparing our two DCs and comparing traffic going from DC1 and DC2 internally on-prem and coming from GCP into one of those DCs, the P99 increase was 83 milliseconds. It was quite low, considering it was a VPN setup quite fast for a single purpose. It wasn't optimized at all. We started with low traffic, 5% runs to validate the rollback. So we knew we could roll in. Getting traffic in was easy. Getting traffic out, we have no answer. So we tried to do these rollbacks quite often. So we get 5% traffic in, get it back, get 5% in, get it back. The developers were used to doing this. Since this was supposed to go live and the developers own their own applications in production, they have on-call rotas for them. If this was live while they were on call, they had to have some tooling to get it back again, even though they weren't involved in the process. So the rollback was another pipeline that they could just retrigger with a lower value or call us and we could switch it off immediately. And the traffic got throttled up gradually by the dev teams along with us and active monitoring. We eventually got to 100% traffic. That meant 100% on GCP and 0% in our two internal DCs. We have 1 million whatever requests during that time. It wasn't a busy time. It was a Wednesday afternoon. It wasn't peak, but it served the purpose of validating the process it needed to be done with rolling traffic in, rolling traffic out, measuring the difference, and getting the devs comfortable with it. So quick, too long didn't read. Ensure all prerequisites are in place before getting your hands dirty. This was a big thing. We have senior developers, principal developers in the project that didn't have access 3 weeks into the project, and this was an 8-week project. So not very good. Terraform, GCP provider, is very good to set up VPCs, VPNs, test labs, development, production environment. The provider for GCP is actually quite good, Terraform one. The GKE Terraform provider is amazing because it's self-managed. So you just say, I want a cluster with these specs, and they will manage it for you. They will do upgrades, they will do rollouts. If it goes down, they will get it back up again. Self-managed, awesome. We had to use a lot of affinity and anti-affinity for Kubernetes because we have VMs deployed with GCP beneath the GKE clusters. So we were trying to optimize the usage. We didn't want to have 3 containers, 48 gig containers on one VM and none on the others. So we got used to using affinity and anti-affinity to set it up properly. Another tip, if any of you is doing this, ensure the rollback strategies. Going in is quite easy. Getting back out and getting to a stable solution after it goes bad, it's really good to train. Using Jib to put Java applications into containers, quite good experience. Way better than running chef cookbooks inside a container. Big applications have feelings too. Take them to the cloud with the others. This was a big thing. Every time we do a cloud POC, we always try to go with the thing we know is going to give us the answer we want to hear. So we've done this in the past. We've done the AWS POC 3 or 4 years ago, and we chose the worst application possible. We chose an Node.js application that was so easy to deploy. The containers were 100 megs. Not containers, they were VMs at the time, but it was a really easy application, and of course it worked. We were checking if AWS was a thing, and it was a thing. That's it, the POC was over. And this question was harder. So getting a big application that is an example or a sample, good sample of your applications is important, even if they are DBs. DBs have feeling too. Do not run config management in containers. This was a big one. We learned the images are big as hell. It's a mess to manage. They take too long to spin up. There are tons of processes spinning things to std out. It's a complete mess. And infra should serve the devs, not the other way around. So sort of like, for me, this is the answer of DevOps. It's getting together to do things for the developers that actually need the infrastructure, not saying, now on you're going to use this because I'm the DevOps dude and I know better than you. And this was quite a good thing. So the devs had their own schedule. We weren't trying to mess things with them. We weren't trying to tell them, we're doing something more important than the work you're doing, so you're going to pay attention to us now. You're going to change your application. You're going to change your cookbooks. And this was a perfect example of us serving them instead of the other way around. That's it. Thank you.
Okay, time for questions.
Ooh.
Oh, fast.
That's quick.
No time to load. Bam.
Hello. Did you have any part of the application that was stateful? Database, data in general?
Kind of stateful. So it maintains state, ideally maintained state. So the application itself was consuming Kafka streams, and that's why the 48 gigs. So it had to consume the whole state of the Kafka streams into memory to be able to use it. And so we could lose state, but we didn't want to, because getting one container down and back up again, it had to get the whole Kafka stream on memory before starting to serve services. And this was actually one of the things we had to understand with Kubernetes is, if you kill an instance, if you kill a container, it will spin it up again. But if you kill 5, it will spin up 5 again. And we couldn't spin up 5 containers at the same time. So this was actually one of the other things we need to set up properly, to only spin up one at a time, and then the other, and then the other. And yeah, so ideally to maintain state, but we could lose it.
Hey, first, good talk and great work. Now I am not feeling alone here in Portugal. The first question is, now you have Kubernetes on the cloud. Are you trying to move to your infrastructure or stay in the cloud?
So we aren't in the cloud, so we went 100% and back. The POC was over by the time of the 8 weeks were done. Everything was shut down. We were hoping to have a live demo today, but we couldn't because our permissions got revoked. So we don't even have access to the clusters anymore. Yeah, the decision isn't really up to us. So it's a big company. It's more of a, I would say, almost political question, because even though the tech bits can be better in one cloud or the other or on-prem, we have loads of Iron bought on-prem already. And this is, I'm talking about 3-4 years ago, we built 2 entire DCs on-prem. So the choice of going cloud isn't just technical, it's budgeting and whatever.
And also we have some regulatory restrictions.
Yeah.
It's a very heavily regulated industry, so there's a lot of stuff which you could put in the cloud, but there's some stuff that will always need to be on-prem. So it's always going to be a hybrid solution.
So for that was the reason I was asking these questions. So you test in the cloud, but Kubernetes can run in premise without any problems, I think. So if it's just a question of you create a POC, you prove that it's easy to run inside of Kubernetes, why not go back and bring Kubernetes inside your data center and run it?
This was actually the biggest gains, more than knowing GCP or knowing JKE. One of the biggest things we got from this experience was Kubernetes hands-on. And one of the things we actually thought of doing is precisely that. So we have loads of Iron bought already on-prem. We could use cloud for all the devs, all the dev environments, using Kubernetes as a basic common denominator, and then deploy all the devs in the cloud and deploy all the prods on-prem. It's actually one of the on standby proposals, but we haven't done anything yet. The whole thing happened in December, November, so.
Hi. How do you manage the configuration, the applications between the clusters from your application? As you saw in some of your slides, you have a cluster for development, one for prod or sandbox. For instance, let's say role-based access control. How do you deploy that or manage this on multiple clusters?
So the clusters themselves were almost replications of our internal on-prem environment. So staging and validation and almost all the Q8s and integration environments were deployed on the dev cluster and all the others on the prod cluster. The developers themselves didn't have, your answer was about root access? Is that it? No. Did I get root access?
Role-based access.
Rule-based, yeah. So the access was, since we only got one application on the cloud, all the requests were going back to our on-prem DCs. So we opened the shared VPN through the shared VPC, and we internally had to authorize requests coming from Google Cloud to those specific applications. It was differentiated between production environments and QA environments, even on-prem and on GCP as well. So we had specific, depending on the cluster the deployment was going to happen, we had different rules being applied to the developer or the production cluster. But we owned those configurations. The developers did not.
Okay.
Okay. Thank you. Thank you, João André.
Yeah, thank you.
Thank you.